All right, guys, so we're back from the interruption with the Zoom. Now, as I was saying to you that if you look at your graph papers or your graph sheets, you should be able to identify about 3 different size boxes. So raise your hand if you are able to do that on your graph paper. All right, so 2 persons. Ms. Brown, do you have graph papers? All right, guys. You have to invest in a graph in a sheet pack of graph paper for this topic, because you're going to be asked to do some graph work too as well. All right. So as I was saying, guys, if you are able to identify these 3 boxes, then the medium-sized box, the one that's I'm going to highlight here now. So the medium-sized box, which would be a box looking like this, the actual measurement of the length of this box. The actual measurement would be 1 centimeter. So the actual measurement lengthwise would be 1 centimeter. Now it's a square, so it means that you would have 1 centimeter square. Go ahead, Miss Brown.
Sir, what are we supposed to do again?
You're supposed to take out a graph paper and identify these boxes that I'm looking at on it.
The big ones that are red as well?
Yeah.
The ones that, okay.
Yeah, if you are able to see all the boxes. So I have highlighted 3 sizes here. So we have a tiny box, a medium-sized box, and one seem a little bit bigger. So are you able to identify those boxes yet, Ms. Brown?
Yes, sir.
All right, so these are the actual measurement, meaning that if you use a ruler to measure it, you will actually get these measurements. You're supposed to get these measurements, meaning that your graph paper is measured out accurately with a rule measurement, all right? And because of that, we can actually do calculation using our graph paper. Now, if you notice with the centimeter box, you will see smaller boxes within the centimeter box. So I am going to ask you to tell me now, lengthwise, how many of the tiny boxes you see in the centimeter box on your graph paper?
Can you repeat for me, please? Because I didn't just hear what you're saying.
Have you identified this medium-sized centimeter box?
Yes, sir, I have.
All right, so the next question now is to tell me how many of the tiny boxes stretching along the length of the medium-sized box. How many tiny boxes?
5, sir.
Right, so everybody identify 5 boxes there. Raise your hand if you see 5 boxes along the length of the medium-sized box. All right, good. Now, if the length of this medium-sized box is 1 centimeter, can somebody tell me what would be the length of one of those tiny boxes? The actual length of one of the tiny boxes will be how much?
0 point.
Go ahead, Miss Wilson, you were saying something about 0 point something. Are you there, Miss Wilson?
Yes, sir.
Yes. You can lower your hand, Miss Wilson.
Oh, I'm sorry about that. Yes, sir. I was saying 0.25.
25 what? What unit of measurement you're using?
Centimeters.
0.25 centimeters. All right. Now, you see, our graph paper is also a metric paper. So it is scaled in the metric system. Now, what do you know in terms of if you divide a centimeter into 10 parts, 1 part would be equal to what? What you call the smaller parts of a division of 10 in the centimeter, guys? Anybody know the metric system? What is the smallest subunit we generally work with?
You're referring to millimeters, sir?
Exactly, we're referring to millimeters. So if we're thinking millimeters, they are much smaller sub-multiple than that in the metric system, but the one that we are really working with is the millimeter. So how many millimeters make a centimeter? So I guess nobody is familiar with their decimal system. Do you have an exercise book? Look at the back of it and look at the table, guys, and see what the unit should be. Anybody see anything on the book back? Or the book back don't carry those things anymore?
Sir.
Yes.
All right, so my book book is showing me that 1 meter is equal to 100 centimeters and 100 centimeters is equal to 1,000 millimeters. So when I did my breakdown now, it would have actually been 10 equal to 1 centimeter.
10 millimeters give you 1 centimeter in terms of the length.
Yes, sir.
Right, good. Because you have millimeter, centimeter, huh? And then meter. So my next question then, in terms of millimeter, what would be the length of one of these tiny boxes? The actual length. How many millimeter we say make a centimeter?
It would be 5, sir. 10 millimeter make 1 centimeter. So because
all right. How many boxes we have in this centimeter?
5, sir.
So one box, the length of one box going to be how many millimeters?
You mean one of the little teeny box, sir?
Yes. What is the length of one of the little teeny box? The actual length.
That would be 1 millimeter.
Brown?
Sir, I don't know if it's right, sir, but I'm just trying. Would it be 1 millimeter?
All right, suppose if in terms of millimeter, you're supposed to have 10 millimeter in this centimeter box. No, sir.
Would it be 20, sir?
No. Think, guys, think. You,
1.5.
no. Think again. You're supposed to have 10 millimeter in this length, right? But instead you have 5 boxes. So one length of that box is going to be equal to what length?
2.
Equal to 2 millimeter. Thanks. Who said that?
Brown.
Raise your hand, the person who said that just now. Okay, thanks, Miss Brown. So, guys, the actual length of these tiny boxes would be 2 millimeters. And these are things that you need to know. You need to know the actual length, because whenever you're using a graph to do calculation, you need to know the actual length, right? All right, so with that said, so this the bigger square, or the biggest square that we have here, what would be the length of it?
4 centimeters square, sir.
Which square you're referring to?
The big one, sir.
We're talking about the one that look like this, right?
Yes, sir. Would it not be 4?
We're talking about the length of it.
Oh.
Lengthwise, if we're measuring it in centimeter, what would it be?
Two, sir.
2 centimeters, good. Because remember now, if you're looking from here to here is 1 centimeter, and you go across another centimeter, then that would be 2 centimeters if you're referring to the length of the bigger square. All right, so these are things that you have to bear in mind. And it is important too that when you're writing your scale, you're referring to the actual length of these boxes when you're writing your scale. Now, so scale-wise now, sometimes we may decide on a scale to use on the x-axis. Now, most of the times our scale might be measured in the centimeter length, right? So on the x-axis, our centimeter length, we know that each of these would be a centimeter. But now we want to say how much unit we are going to make one of these centimeter represent. So if we start here at 0 and we start counting 1, 2, 3, 4, 5, 6, 7, 8 on the x-axis. What would be the scale on the x-axis?
One to 8, sir.
What is that? Ms. Raysom, was that you?
Yes, sir. I was saying 1 to 8.
When you say 1 to 8, what do you mean?
Because you're counting all the way out to 8, sir.
No, That's not the scale. Your scale is what you're using in the actual measurement to represent 1 unit. That's your scale.
Oh, so you mean you'd have got 8 centimeters, sir?
No, we're thinking about in terms of 1 unit. We're not talking about in terms of the 8 units that are there.
Okay.
So on this, what is the measurement? What is the actual measurement between 0 and 1? The actual measurement.
10 millimeters, sir.
All right, but we know that 10 millimeter equal to what?
1 centimeter.
Right. So preferably we are going to refer to these as centimeters. So from 0 to 1, how many centimeters we have?
1.
1. So it means that our scale on the x-axis, we are using 1 centimeter to represent, or you can, if you don't want to use the word to represent, you could say 1 centimeter equal to 1 unit on the x-axis. So that is the scale. And oftentimes you are required to write your scale when you're doing a graph. If you don't put your scale, you lose mark. Generally, they give you a 1 mark for your scale. So if you have the scale for the x-axis, you must also have a scale for the y-axis. Now, suppose on the y-axis, I am counting here now. So I say 4. All right, let me use a different number. So I'm counting and I say 3, 6, 9, 12. Now, what would be the scale on my y-axis?
1 centimeter representing 3 units, sir.
Exactly. So that would be the scale for the y-axis. So you have to write both scales on your graph paper. All right. And generally you can write it depending on if you have any little space below the grid. Sometimes you write the scale on that little this white space below the grid. Or some people may look at a space on the grid where the graph itself is not being plotted and write the scale there neatly. So you have to write the scale neatly. So you have to do it for both axes. So for the y-axis, you use 1 centimeter equals to 3 units on the y-axis, right? Now, as I said, there are times when you can use the same scale on the y-axis, and there's no problem with that. But depending on the range of values that you're working with, so maybe on the x-axis, your range of value going from 1 to 8, and so those values you can easily write them with a scale of 1 centimeter. But you may be using range of values on the y-axis going from 1 to 100. Now, you couldn't use one of these centimeters to be 1 if you're counting to 100. What would be appropriate if you are going to use, suppose you want to represent 100 units on the y-axis, what would be an appropriate scale for the y-axis?
10, sir.
That is not a scale. Did you give me a scale? by just saying 10 this way, so?
1 centimeter is used to represent 10 units.
Right, so that would be your scale. So to accommodate that range of values, now you have to use a more suitable scale on your y-axis. And so it is important to know that the scale that you use should be appropriate for the range of values that you're going to put on that scale. Because sometimes what you want is to give a clear picture of your graph. And to get a clear picture of your graph, it is better to have graph that you can work with larger scale so that when you draw your graph, you get a bigger picture. And that is, remember, the purpose of a graph is to give you a picture. And so you don't want to use a tiny scale that when you draw your curve or when you draw your graph, you get this squint drop curve. Please, students, don't do that. Make use of the entire size of your graph paper and make your scale large enough so that your diagram can be as large as possible. And that's what you're expected to do when you're selecting your scale. Make your scale large enough so that you can have a clear visual of what you're drawing. All right, so the appropriate scale that you would use if you are representing 100 units on the y-axis, you could make 1 centimeter equal to 10 units. So you would count and count by 10 goes up, go all the way up. So you'd have 10, 20, 30, 40, etc. All right, is that clear to everyone? So you can choose the scale of your choice if they don't give you what scale to use, they may ask you to use a scale of your choice. So in that sense, you will have to choose a scale appropriate for your graph. Is everybody clear on how to determine your scale? Guys, raise your hand if you are clear on that. All right, this way some. Miss Brown, who else? All right. All right, guys. So with that said, everybody should be comfortable with your graph paper now. Now, drawing a graph. Now, every graph shows a relationship between at least 2 sets of values. A table is used to show the corresponding values of X and Y. So what in this table, what you notice is that we have the X values in the top row and the Y values in the bottom row or the row below. And that is generally how we construct our table. So this would be a horizontal table. Now, there are some textbooks that may give you the table vertically. And then if you draw this in a vertical sense, you would probably put the X values on the left and the Y values on the right, if you're making a table vertical, right? Now, the Americans tend to draw their tables vertical, but for this text that we're using, your table for your coordinates will be horizontal most of the time. All right. Now, if you're given this table, then what this table is giving you is a relationship with the X and Y coordinates. So what they're saying then, if you have an X value of 0, then that corresponds to a Y value of 0. So if you pair these two X and Y values as coordinates, you would write the X value first And so this would be the 0 for the x value, and then now this would be the 0 for the y value. So you write your x coordinates first, and then you write your y coordinate. That's how your coordinates is written, right? And so here again now for the x value 2, we have a corresponding y value 4. So if x is equal to 2, y is equal to 4. And so this is how we write them in the coordinate form. So this would be your x value, this would be your y value. And so you make that corresponding x and y relationship with all of your x and y values. And so you will have your points. Go ahead, Ms. Brown.
Sir, this is a random question, but is construction going to be on the CSEC paper?
Well, there are, as you know, there are changes on with the syllabus. I think they will have construction, but not as complicated as in previous years. So they make a simple construction, and it is generally probably integrated in a question. All right, does that answer your question?
Yes, sir.
If you are not very clear, on the website, just check the syllabus and see what is required there, because everything that is required is in the syllabus. If you don't want to go through the task of checking what the syllabus is saying, there's a video that was posted in the class notes 1 at the beginning, where they speak.
Sir, another question. Every school gets the same CSEC paper?
Well, that's generally the case, but I don't know if in recent time CSEC do anything in terms of the papers, in terms of the COVID period, but generally every school would get the same paper, not just in Jamaica alone, but right across the entire Caribbean. Does that answer your question?
Yes, sir, thank you.
Right. So whatever paper that you sit in at your school, the other students in other schools are sitting the paper. It is a standard paper. That means everybody is tested by that same paper. All right. All right. So any other question before we move on from this? Now, what I want you to do for me, guys, this table that I have here, I want you to do your first practice with your graph. Now, if you notice that these values are positive values for the x, and they are positive values for the y. So on your graph paper, you don't need to have a negative part of your x-axis, and you don't need to have a negative part of your y-axis. So what I want you to do is we are going to practice plotting these points on your graph paper. So to plot these points, you need first to choose a suitable scale. All right. So I'm going to ask you to choose a scale of your choice for both axes, right? So, and the scales don't have to be the same on both axes, but if you decide to have them the same, that's up to you. So you're going to choose a scale for both axes, and then now you're going to plot the corresponding points. So I'm going to go back to the graph paper and see if I can illustrate for you what you're supposed to do. And I'm expecting now that you guys should be doing that. Everybody is seeing what is on the screen? Everybody is seeing what is on the screen, guys?
Yes, sir.
Yes.
All right, so you need to first write this table on your graph paper. We generally put the table of our graph on the graph paper. So at the back of your graph paper, you're going to write this table and put in all the X values and all the Y values as they are in the table here. Now, why we need to have a table on our graph paper? Because whatever graph we're plotting on the graph paper will come from that table. And so you'd like to be able to check using that table to see whether or not you plot your graph correctly. Is that clear, guys? All right, so with that said, let me know when you're through writing your table. And then the next step, I am going to ask you now to draw your X and Y axis. And then now you put use an appropriate scale. Now this is what you can do, guys. Now on your graph paper, sometimes some students may use the edge of the graph paper if they are just working with positive Y values. Sometimes they use the edge of the graph paper to be their axis. All right, so that's one option. You can draw your axis along the edge if you are working with positive values for both axes. Now, if you don't want to draw your axis at the extreme edge, you could step in your axis, you could step your axis in if you may, you can step it in 1 centimeter if you want. Depending on how you want your graph to look, all right? But in general, as I said, in general, we can use the edge of the paper to draw our axis. So after you have drawn your axis now, the next step you want to do, and you should label your axis too as well. So you draw your axis, you label this one Y, and you label the other one X. Now, generally our axis, it's a number line. So we put an arrow tip at the end of each axis to show that this line continues, all right? So you need to put an arrow tip on your axis, all right? Now, the next step, you want to choose a scale for the X-axis and you want to choose a scale for the Y-axis. But before you jump and choose a scale, look at the values in your table to help you to do that. So for your table, the x values go from 0 to 8. So it means that on your x-axis, you're going to check how many centimeter boxes you have. So if you start off at the point of intersection of your axis, then you'd have 0. So you count how many centimeter boxes you can get from that point to the right. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, the fact that this one lands on the edge of the graph paper, we could put it there if we want, no problem. So we could now label this axis using a scale of 1 centimeter equal 1 unit on the x. So you would write your scale for your x-axis. Now, guys, you don't have to use the same scale that I'm using here. You can choose any scale that you see appropriate for your graph or your axis. Now, suppose you wanted to use 2 centimeter, suppose you wanted to use 1 centimeter to be 2 units. Then you'd have 2, 4, 6, 8. But what you notice here is that you would have a smaller distance over which you are to spread your values. So it means that your graph is going to be smaller when you use smaller units. So I would suggest use the largest units that you can use. So for the x-axis, we're going to use 1 centimeter equal 1 unit. So we have 1, 2, 3, 4, 5, 6, 7, 8. All right, guys. Now on your